Let's take another example. This example says, solve 4x subtract y plus 1 equals 0 for y. Once again, we're solving for y. Solve 4x subtract y plus 1 equals 0 for y. The letter that's designated is y. We want to get y by itself. Notice that everything in the problem that's very interesting is on the left-hand side. The right-hand side only has the number 0. Adding 0 to something will not change it. On the left we have the x term and the y term and the constant term. We want to get y by itself. To get y by itself, we can proceed in one of two ways. We can either remove from this left-hand side the x term by adding its opposite, and the constant by adding its opposite. Or we can remove from the left-hand side the thing that we really want by itself, which is the y term, by adding plus y. We can either remove terms by adding twice, or remove the term we want by adding once. Let's be efficient about it and add y to both sides. So I'll add y to both sides. This is a bit different from what you might expect. We'll add y to both sides. Now on the left we have 4x subtract y plus 1 add y is equal to 0 add y. On the left, subtracting y and adding y cancel. So we're left with 4x plus 1. On the right, 0 plus y is simply y. And so we have 4x plus 1 equals y. Our job was to get y by itself on one side of the equation. We have done that. Y is by itself on one side of the equation. And so we can stop here. Most of us would feel better about the way this looks, however, if we wrote the y on the left and the expression on the right. Remember that you can always take the two sides of an equation and interchange them. And so we can write this as y equals 4x plus 1. And here is our preferred version for this problem. Y equals 4x plus 1. For our third example, let's take a formula. This formula you may recognize as a formula for the area of a rectangle. Area is equal to length times width. We don't need to know where the formula came from or what it's all about to be able to do what we're asked to do, which is to solve for w. So we take a is equal to LW and solve for w. To get w by itself, we must remove its coefficient, which is L. To remove a coefficient, we divide by the coefficient. And so we copy the equation, a is equal to LW, and divide both sides by L. On the left we have a divided by L, which cannot be simplified. On the right, LW divided by L, the L's cancel, leaving W. And so we get a over L is equal to W. We have done what we're told to do, which is solve for W. W is alone on one side of the equation. We might prefer to write it with W on the left-hand side. If so, we'll write W is equal to A over L as our final version. Either of these versions is perfectly correct. The only advantage to the second one is it feels more like the usual form, where we have the letter we're after alone on the left instead of on the right. Let's do one more formula. This is a formula from business. This will be more complicated. Our formula says P is equal to R subtract C divided by N. P is equal to R subtract C all over N. And we're to solve this for the letter C. We're to solve for the letter C. Remember that in solving an equation, our first step is to simplify each member of the equation. The left-hand side is, of course, as simple as it can be. The right-hand side cannot be simplified either because none of these letters match. So even decomposing the fraction will not be of any help. And so our next step is to remove the fractions by multiplying by a common denominator. We have a fraction, denominator n on the right. On the left, of course, the understood denominator is 1. And so we can multiply both sides of this equation by n. On the left, n times p. On the right, n times the expression r minus c over n. On the left, we get n times p, which is np. On the right, the n's cancel, and we're left with r subtract c. And so we get np is equal to r subtract c. We're trying to get c by itself. Now that the fractions are gone, we sort laundry. The c is to be gotten alone. That means we must remove the r from the right-hand side of the equation. So we remove r by adding its opposite. So we have np add the opposite of r. On the right-hand side, we have r. I'm changing subtract c to add the opposite of c. Add the opposite of r. So we add the opposite of r to both sides of this equation. On the left, we cannot combine anything. On the right, we can cancel the r and its opposite to get the opposite of c. Now to get c by itself, we must remove its coefficient, which is understood to be -1. And so we divide both sides of this equation by -1. On the left, we can decompose this fraction because the -1 denominator underneath each part can be simplified out in some places. And so we'll decompose to get np over -1 plus the opposite of r over -1. And on the right-hand side, the opposite of c divided by -1 is c.